Assalamu alaikum dear students. This is our next problem having been chosen from the book Modern Physics by Stephen T. Thornton and Andrew Rex. Okay, Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, a spaceship of length 40 meter at rest is observed to be 20 meter long when in motion. Okay, 40 meter at rest while 20 meter in motion. Length contraction has become relevant here. Okay, how fast is it moving? Okay, quite simple. In order to solve this problem, we need just one snapshot, one expression, one relation, one equation. Okay, nothing else. So as usual, we first discuss that snapshot within the framework of which our solution will fall absolutely. Okay, length contraction, the length L naught of an object measured by an observer in an inertial reference frame in which the object is at rest is called its proper length. Observers in frames moving relative to that frame and parallel to that length will measure a shorter length. For an observer moving with relative speed v, the measured length is L equal to L naught into under root 1 minus beta square. Dear students, beta is called speed parameter. It is equal to V over C. Okay, this becomes equal to L naught over gamma. That is, gamma Lorentz factor is equal to 1 over 1 minus beta square, or Lorentz factor gamma equal to 1 over 1 minus V square over C square. Okay, this phenomena is called length contraction. Okay, so using this single expression, using this single equation, by putting the concerned values in this equation or expression, we can reach our answer quite comfortably, quite easily. Okay, using L equal to L naught 1 minus beta square under root, where beta is equal to V over C and is called speed parameter. Okay, this implies that 20 meter is equal to 40 meter into 1 minus beta square. Okay, because L is 20 meter and L naught is 40 meter, this implies that 1 minus beta square under root will become equal to 0.5, because 20 will be in the numerator and 20 meter will be in the numerator and 40 meter will be in the denominator, and our answer will become 1 by 2, or in other words 0.5. If we take, when we take a square on both sides, then instead of in place of under root 1 minus beta square, we will get simply 1 minus beta square. Okay, so 1 minus beta square will become equal to 0.25. Okay, square of 0.5 is 0.25. Okay, because 1.5 is 1 by 2 and square of 1 by 2 is 1 by 4, and 1 by 4 we know that 0.25. Okay, from here we move beta square on other side of equality, and similarly we move 0.25 on other side of equality. We get the shape beta square equal to 0.75. This implies that beta equal to 0.866. What is this? We have taken under root on both sides, and under root of 0.75 is 0.866. Beta speed parameter is V over C, so in place of beta we can also write V over C equal to 0.866. This implies that V becomes equal to 0.866 c, where c is speed of light. 3 into 10 raised to the power 8 meter per second, or 2.998 into 10 raised to the power 8 meter per second. This is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.